Welcome back, everyone. My name is Refilwe Madilola. I'm your tutor for today from Academic Solutions. Picking up from where we left off, we'll be doing topic 3, which is about wave, light, and sound. Wave, light, and sound. Excuse me, I was just trying to expand the screen. Oh my god, it took me from the beginning. Okay, let's just quickly slide through all that we have covered. Yes. So we are on topic 3, wave, light, and sound. So what is wave? Waves involves transport of energy without the transport of matter. In In conclusion, a wave can be described a as a disturbance that travels through a medium, transporting energy from one location to another location without transporting matter. Waves. To understand waves, we must be able to identify the quantities acting on them. These include amplitude, wavelength, frequency, the period, and the wave speed. Amplitude is the maximum disturbance of a particle from its rest position. Wavelength is a distance between two consecutive points in a phase, i.e., the length of one wave. Frequency means the number of waves passing at a given point per unit time. The period refers to the time it takes to complete one full wave. Wave speed means the distance a wave covers per unit. These are all the terms associated with waves: amplitude, wavelength, frequency, period, and wave speed. Waves. The picture below, the picture that you see on your screen, uh, it describes the relationship of each quantity in relation to a wave. As we have mentioned, the amplitude, the wavelength, the troughs and the crest, and the direction of the waves. Light. Moving on to light. The nature of light. Light has a dual nature. Number 1, waves nature. Light travels in waves nature. Light travels in transverse waves. Number 2, in particle nature, the particle nature of light, light travels in quanta of energy called photons. Photons move with the speed of light always. Light and optics. Light is one of the radiations in the electromagnetic spectrum. Optics refers to the study of the behavior and characteristics of light. When we say the light has a particle nature, because of its ability to polarize. Through polarization, light allows particles to move in one direction. We can also deduce that light is transversal by polarization. What is polarization? Polarization, cross-polarized lenses. Cross-polarized lenses, light is emitted in many directions from one source. A polarizer is used to align particles in one direction, e.g., a Polaroid filter. Thereafter, light in one direction is transmitted parallel to a polarizer, and then light is transmitted at right angles. Pointers to take from the light subject is that light is able to travel in a vacuum unlike sound, but it can also travel in a medium. A medium is an object that allows light to move through it, for example, a glass. Different media allows light to pass through them at different extents. This is called optical density. The optical density of a medium signifies the proportion of the distance that light ray travels per unit time, i.e. speed. Therefore, light travels slower on an optically dense medium. Some surfaces allow light to travel through from one side to another. They are said to be transparent or see-through. Some surfaces, very dense to the point that light cannot travel through, are called opaque. Reflection. Reflection refers to the bouncing back of light. Spatial reflection is a type of reflection that happens on a smooth surface. As you can see, the surface is smooth, it's straight, it's not corrugated, or there's no any form of disturbance, it's just smooth. Reflection, still on reflection, a diffuse reflection is a type of reflection that occurs on an uneven or a rough surface. As you can see, the surface, it's not smooth. There's sort of a lot of hips. Yeah. Looking at the law of reflection, the law of reflection states that when the light is reflected on a smooth surface, the angle of incidence is equal to the angle of reflection. As you can see here on the image, the incident ray, the angle of incident ray, which is theta I, it's equal to the reflected ray, which is theta R, and the surface is smooth. The different components that form part of the reflection process. Incident ray. This is the ray striking the surface of an object, coming towards the surface. Then moving on to reflected ray. Reflected ray, this is the ray that opposite direction. That is in the opposite direction to the incident ray. That is moving in the opposite direction to the incident ray, going away from the surface. Normal. The normal is an imaginary line that is perpendicular to the surface of the medium. It is in the plane where the incident ray and the reflected ray act. Angle of incidence. The angle of incidence is the angle between the incident ray and the normal. Angle of reflection is the angle between the reflected ray and the normal. We have different types of mirrors. We'll look at the plane mirrors, mirrors that create an image that that's the same size as the object. Plane mirrors, those are called plane mirrors. Concave mirrors, these mirrors have a converging focus. They are good on concentrating lights to a single point. And then we have convex mirrors, mirrors that have diverging focus. They allow a wider view of the area. Concave mirrors, if an object is far, the real image is formed at the focus. The image is inverted and smaller than the object. Now we look at refraction. Refraction refers to the change in the direction of a light ray. That's where Unit 3 ends.